Hello class, and welcome to another video lesson. Today we are on section 2.2 and 2.4 with our notes being continued. On this particular video lesson we're going to be writing the equation of a line given its graph. So for example, on this first problem, here we have just a snapshot of this line. This blue line, as we know, goes for infinity down and to the left, and it goes for infinity up and to the right. So what is happening here is we just have a snapshot of this line that goes for infinity. We just have a snapshot of it, and what we're going to do in this case is we are just going to write the equation of the line that works for every single point on this line. So as you can see here, it says answers must be in slope-intercept form. Well, you're going to be quite lost if you have forgotten what slope-intercept form is. So let's review that. It is y equals mx plus b. So as we talked about in our last lesson, y and x, those remain unknown in your equation. Those are ordered pairs, not specific ordered pairs, but they represent every ordered pairs. So what we need to find is we need to find m and we need to find b. Once we have those two, we just simply substitute it into our equation and we are done. Remember what m means. M is the slope. Remember what b means. B is the y-intercept. So as long as you have those two pieces of information, we are set. On this particular graph, do you have the slope and do you have the y-intercept? Well, let's first start off by finding that y-intercept. Where does it cross the y-axis at? It crosses right there. So it is at a positive 1, 2, 3. My b equals a positive 3. Do you know what your slope is? Your slope. Class, we talked about this last video lesson. Our slope is equal to y2 minus y1 over x2 minus x1. And I definitely have no problem with you using this equation. In fact, it's probably a great idea. However, it might take a little bit longer than just counting using your index finger, such as this. You know that it goes through this point right here. And you also know that the y-intercept is, like I said, at a positive 3. So now just use your index finger and count rise over run. This goes up 1, 2, 3 units. Your rise is 3. How far does it run to the right? It runs 1, 2. Your run is 2. So your slope, class, is 3 halves. And you would get that using your slope formula of y2 minus y1 over x2 minus x1, but it's probably just easier just to count it in this case. So you have your y-intercept as being 3, you have your slope as being 3 halves, and now all you have to do is put this information into this equation. So it's going to be y equals 3 halves x plus 3. And there you have it, class. You are all done with number 1. Moving on to number 2, we have to look at the graph and we have to say, I want the equation of this graph in slope-intercept form. So I always write down y equals mx plus b. That helps me strategize as to what I need. So I need to find m and I need to find b. If you're looking in this one, do you know where this one crosses the y-axis at? What is your y-intercept? Well, you know it crosses right here. Now here's the tricky question that I'm going to ask you, class. Do you know exactly where that is? You might say yes, you might say it crosses at 2.5. However, does it have to cross at a half right here? Couldn't that be maybe 7/12 instead of 1/2? 7/12 and 1/2 are very, very close to each other, but they're not exactly the same. So I can't conclude exactly where this point is. So because of that, I can't know exactly what my b is just by looking at the graph. My slope, however, I can find exactly where that is. And that is because we know it crosses right here, and we know that the graph crosses right here. So we can now find our slope. Our slope is a rise of a -1, and it's a run of 1, 2, 3, 4, 5, 6, 7. Our rise is a -1 over my run of 7. So my slope is a -1/7. So I know my m is a -1/7, but I don't have my b. So class, when this is the case, we also had a point slope formula. Our point slope formula was y minus y1 equals m times the quantity, x minus x1. I have my slope, and I have a point. We actually have 2 points. I could use this one, or I can use this one to get it into this equation where we're given x1 and y1. It doesn't matter which one we use. Let's use this one because both of them are positive numbers. So this point is at right 1, 2, 3, 4, and up 1, 2. This green point right here is at 4, 2. So with that, let's put this information into our point slope formula. Y minus the y coordinate of 2. That equals my slope, which is a -1/7, times the quantity x minus my x coordinate, which is 4. So this is my answer in point slope form. However, it says all answers are to be in slope intercept form. So let's put this in slope intercept form by distributing and then getting it into y equals mx plus b form. Distribute here, distribute here. I get y minus 2 equals a -1/7 x. Negative times negative is a positive. 1/7 times 4 is a positive 4/7. And now all I have to do is get rid of this 2. That way I'll get into y equals mx plus b form. To get rid of that 2, I have to add 2 to both sides. So for my final answer, in slope-intercept form, the graph has this equation. Y equals a -1/7 x, 4/7 plus 2. You can do this in your calculator. 4/7 is the same thing. 4/7 plus 14/7, which is the same thing as 2, which would be 18/7. And there's my answer for number 2. I was given my graph. With my graph, I was able to find my slope. However, I wasn't able to find my y-intercept. So if that's the case, you have to put it into point slope form and then change it into slope-intercept form. Y equals a -1/7 x plus 18/7. Moving on to the next one, number 3 is actually very, very simple. Whenever you are given a complete horizontal line or a completely vertical line, you don't even have to think of y equals mx plus b. What you should be thinking of is a horizontal line is x equals a number. I probably shouldn't have had equals twice there. When you say a horizontal line, what you should conclude is that it's x equals, when it's a horizontal line, you should think y equals a number. Horizontal, y equals a number. When it is a vertical line, you should think x equals that number. And that's all you need to know for this one. It is a vertical line, so you know that that equation is going to be an x equals line. X equals a number, and what number is that? It's the number that it crosses. Here's 1, here's 2. So it's obviously x equals 2. And you are done. If you got something on a worksheet or if you got something on accelerated math with a line that looks like this, well, that line is a horizontal line, so you know it's going to be y equals, and y equals what number? Here's 1, here's 2. It's obviously y equals 3. So that's what happens when you have a horizontal or vertical line. Last one, number 4. Why don't you guys pause the video, try this one on your own. Alright, hopefully you found that if I want these in y equals mx plus b form, as long as I know my slope and as long as I know my y-intercept, I'm golden. Do I know what my y-intercept is? It crosses at 1, 2, 3. My y-intercept is 3. Do I know what my slope is? Just find any 2 points on the line and count out your rise and your run. It goes down 1. It goes right 1, 2, 3, 4. Your slope is a negative 1/4. With this, you simply put it into y equals mx plus b form. Y equals your slope of a negative 1/4 x plus your b, which is a positive 3. In class, the reason why this is helpful is because, once again, this graph is just a finite picture. It has an end, it has a beginning, it doesn't tell you everything about the line. A line is infinite. That's why this equation right here is so beneficial to us. Instead of just giving us a snapshot, it gives us every single ordered pair on that line. You simply put in an x coordinate, you'll get the y one. Or put in a y coordinate, you'll get the x one. This tells you an infinite number of things. This one is finite, which means it has a beginning and it has an end. So that is our first part of the lesson for today. I will record another lesson for the second half of the notes for today.